Okay, so the next derivative rule that we're going to be going over is the sum and difference rule. And basically what this means is if you take the derivative with respect to x of f of x plus g of x, then it's simply equal to the derivative of f of x and the derivative plus the derivative of g of x. So you can, in a way, you can almost distribute this derivative to each of these, and the same thing works with subtraction. So the only thing that changes is the subtraction sign. Now to prove this, I'm going to use a little bit of algebra and our limit notation. So we're going to start first with our definition of what a derivative is right here, and then I'm going to input what our function is. So our first function for this f of x plus h is this right here, only instead of x's we have x plus h. So I'm going to set this equal to the limit as h goes to 0 of f of x plus h plus g of x plus h, and then I'm going to put brackets around this term right here. So this first term right here represents this part of our derivative definition. Now these f of x's might get confusing, but just know that our new function is these two things added together, so don't get it confused with this f here. In fact, I'll just take out the equal sign to make it a little bit easier. So I'm going to put a box around this to separate it. Okay, so that's our first term, minus f of x. So that's just when there's x's as our input. So I'm going to put f of x plus g of x, like so. So I have this term and this term. Now I have to divide all of this by h. Now, based on our properties of addition and subtraction, it doesn't matter what order I have for these. So what I'm going to do is simplify it to be this f of x plus h minus f of x. So I'm just going to group the f functions together, like so, and then I'm going to divide it by h. Okay, and I need to bracket again. Okay, then I'm going to do the same thing with the g of x. So I'm going to do plus g of x plus h minus g of x, like so, and all of this right here is divided by h, then I have a bracket. Okay, so if you remember our limit properties, one of the limit properties is that you could break up the addition of whatever you're adding. In this case, we're adding the f function and the g function, so I'm just going to separate them where it says the limit as h goes to 0 of f of x plus h minus f of x over h plus, this is where our limit property comes into play, limit of as h of the limit as h goes to 0 of g of x plus h minus g of x over h. What I basically made here is this whole thing is a derivative, the definition of a derivative. This whole thing is also the definition of a derivative. The only thing that's different between these is the function. This one's f and this one's g. So I'm just going to write f prime x here plus g prime x here. And if you notice, starting out with what we started with, you end up with proving this first rule up here, the sum rule of derivatives. Now, I'm not going to do the difference one because really it's the exact same thing, only the sign changes right here to a minus. So this would be a minus, minus, this would change to a minus, and this thing right here would change to a minus, which would change this to a minus. So it's the exact same principle, exact same algebra, the sign just changes. So if you have any questions on the sum and difference rule, let me know.